Alex, is the Job Guide 360 interview guide worth it?
Honestly, yes, the guide is highly insightful. I recommend it to everyone.
Welcome to the deep dive. Today we're looking at something really fascinating, I think. We've got these sources that map out the whole career path for mobile application developers.
Yeah, it's quite a journey.
Exactly. And we're using actual interview questions, from the very beginning, the junior level, all the way up to folks like architects and managers.
It's a great way to see how the job changes.
Right. To understand how the expectations just evolve so much.
Mm-hmm. And fundamentally, the core role is designing, building, maintaining apps, using Swift, maybe Kotlin for native stuff.
Or React Native for cross-platform these days.
Or React Native, yeah. But the real mission here for this deep dive is to see where those big shifts happen.
Okay, yeah, let's get into that. The mission.
Yeah.
Finding those points where it changes. Like a junior dev is focused on, writing code, right?
Yeah.
Making features work.
Pretty much, yeah. Getting things functional.
But then you jump to an architect, and suddenly it's about long-term system health, scalability.
Completely different mindset. And the manager is thinking about the team, about productivity.
It's a total shift from just being good at coding to being like a strategic player.
Exactly. So let's start at the start. Junior mobile application developer. This is where you prove you can actually do the work, not just talk about it.
Right. Question 1.1 in our sources asks about a previous project. What makes someone stand out here? It can't just be, I built an app, can it?
Definitely not. You need
Yeah.
specifics. What were your responsibilities? What tech did you use? Maybe Flutter for the front end, integrating some APIs for data.
Okay, but the sources emphasize the challenges, right? That seems key.
Absolutely. That's where you show real technical skill and problem solving. For juniors, a common struggle mentioned is state management.
State management. Why is that such a common headache early on? Isn't it just variables?
Well, not really in complex apps. Mobile apps are super interactive. Things happen asynchronously. You tap something here, data needs to update over there instantly.
Right, okay.
If you just use simple variables everywhere, it becomes, spaghetti code. Really fast, unmaintainable.
Gotcha. So the junior needs to show they get that complexity. And the example solution cited is using something like the provider package.
Exactly. Implementing something like provider shows they hit a known problem, researched it, and used a proper solution, not just hacking something together.
So it shows they learned and applied.
Huh.
Okay, step 1, prove you can build. Step 2.
Prove you can fix things. Debugging. Question 1.2 is all about that systematic approach.
Yeah, you can't just guess, right?
Yeah.
Change code randomly and hope.
Please don't. No, we need to see a structured method.
Yeah.
How do you reliably reproduce the bug? How do you narrow it down? Isolate it.
And using the right tools, presumably, like the debugger in Android Studio or looking at Logcat, setting breakpoints.
Precisely. Using the tools effectively, we have a good example here. Fixing a crash, a null pointer exception, in a quiz app during data loading.
Okay, so they track it down, maybe using breakpoints, find the null value.
Fix it with better error handling, sure. But the really important part, behaviorally speaking, was documenting the bug and the fix.
Documentation. So it's not just about the fix itself.
It's about learning from it. Updating tests, maybe, so it doesn't happen again. That turns a single fix into team knowledge.
That makes a lot of sense.
Yeah.
Okay, so building and debugging, that's the foundation. What's the next big leap? Moving beyond junior.
This is where it gets really interesting, like you said. The jump to mid-level. The sources show a clear shift. It's less about just pure technical execution.
And more about?
More about the user, integrating their perspective. You could write the most perfect code, but if users find the app confusing or frustrating...
It's a failure. Doesn't matter how clean the code is.
Exactly. So question 2.2 asks about a project that needed significant user research. The mid-level dev needs to be proactive here.
How so? What are they doing?
Gathering insights, maybe through surveys or actual user interviews, usability testing sessions, and then critically translating that feedback, which can be kind of vague.
Yeah, make it easier. What does that mean technically?
Right. Translating that into concrete technical specs. That's the skill. They start acting like product developers, not just order takers for code.
Okay, I see. The example given was adding social sharing, right?
Yeah, and the design of that feature, how simple and intuitive the interface was, came directly from insights gathered in user interviews.
And did it work?
The results showed a 30% increase in content sharing. That's not just a tech win, that's a huge business value win. Engagement, potentially virality.
Wow. Okay, so that directly links their technical choices to business outcomes. That's a clear step up.
Definitely. And the projects themselves get harder. Question 3.1 expects mid-level candidates to discuss genuinely complex challenges. They often suggest using the STAR method here.
STAR. Situation, task, action, result.
Exactly. To structure the answer clearly, it shows you can analyze a complex problem and explain your solution methodically.
And the example involves performance.
Yeah, a classic one. An e-commerce app with slow load times because of too many large images. Users are dropping off.
Can't just tell them to be patient.
Nope. So the action involved technical solutions like image compression, maybe setting up lazy loading.
Lazy loading. So images only load when you actually scroll to them.
Right. Reduces the initial load dramatically. And the result, a 40% improvement in load times. But even better, a 25% increase in customer retention.
See, again, connecting tech to business metrics. Fixing a real problem that was costing users.
It's about solving bigger problems now, impacting the bottom line.
And across these roles, mid-level and up, there's this constant theme of learning, right? Questions 3.2 and 4.2 hit this hard. How do you stay current?
It's non-negotiable and mobile. Things change so fast, but you can't just list a book you bought. You need to show you're actively doing it.
So what does active look like?
Reading specific, respected blogs medium, Ray Wenderlich are mentioned, listening to relevant podcasts like The Changelog, being part of communities GitHub, maybe Slack groups.
Okay, consuming information. But how do you filter? There's so much noise, so many new frameworks popping up constantly. How do you know what's actually worth learning?
That's part of the skill, the strategic thinking. You show judgment. Maybe you learn Flutter because you see its potential for productivity. You try it on a side project first.
Test it out yourself.
Right. See if it actually delivers benefits like faster development or easier maintenance. Then you can make a case for using it at work. It's about applying the knowledge and validating it, not just collecting buzzwords.
Okay, that makes sense. Prove the value through application. Now we're moving into leadership territory, senior and lead roles.
Yeah, and here the game changes again. It's less about your individual coding prowess.
And more about the outcome of the whole project, leading others.
Exactly. Question 4.1 asks about a project you led. The scale is immediately bigger. The example is leading a team on a mobile payment app, using Swift for iOS, Kotlin for Android, the native stacks.
Payments. That sounds high stakes. Security must be paramount. But don't platforms like Apple Pay or Google Pay handle a lot of the heavy lifting on encryption? What's the senior dev specifically worrying about?
Great question. They're responsible for the security of data within their own app's domain before it even gets to the secure platform elements. Think about data in transit between your app and your backend, or sensitive user info stored temporarily on the device.
Oh, okay. PII, personally identifiable information.
Right. So they need to implement advanced encryption for that, maybe custom protocols. Rigorous testing is key penetration testing, auditing third-party libraries for vulnerabilities. They're basically the guardians against major security breaches.
So their technical skill is now mitigating huge business risks, legal, financial, reputational.
Absolutely. And the result in that payment app example, a 30% faster transaction speed. That directly improved the user experience, which boosted client retention, technical leadership driving business success.
Okay, and then lead developers. That just senior developer pluses?
Sort of, but with a stronger emphasis on certain areas. Performance optimization, for instance, becomes a core leadership task, according to question 5.1.
Meaning they're not just fixing performance bugs they find.
No, they're defining the performance standards for the entire team or product. They're setting the bar and ensuring everyone meets it. They need a formal process.
What kind of specific techniques might a lead implement that go beyond, say, the mid-level dev's image optimization?
Thinking more system-wide. Maybe aggressive asset size reduction through automated build pipelines, implementing sophisticated caching strategies, and crucially, measuring everything systematically.
How do they measure?
Using tools like Firebase performance monitoring or similar platforms, getting real-time data on how the app is actually performing out in the wild for real users.
And the payoff can be huge.
The example cited achieved a 50% drop in load times. That led directly to a 30% jump in user engagement. Speed isn't just nice to have, it's often the difference between success and failure.
Wow. And because it's a lead role, collaboration is also front and center, right? Question 5.2.
Fundamental, but it's not just playing nicely, it's about actively designing and managing the team's workflow. Optimizing how this group of, let's face it, often complex technical people work together effectively.
So methodology meets soft skills.
Precisely. You implement agile practices, daily stand-ups for sync-ups, maybe bi-weekly sprints for predictable delivery, But the soft skills are just as critical. Facilitating discussions, resolving conflicts constructively.
Building that sense of shared ownership.
Exactly. Making sure everyone feels empowered to raise issues and contribute to the solution. That's active leadership.
Okay, now we're at the top. The strategic view. Mobile application architect. This sounds less about day-to-day coding.
Much less. Think of them as designing the city plan, not building individual houses. Question 6.1 is all about designing for scalability and maintainability from the outset.
You hear terms like MVVM or clean architecture. What do those actually mean for someone not deep in the code?
Good question. Think of it like building a complex machine. You want clear separation between parts. MVVM or clean architecture are like blueprints that enforce that separation.
Separation of what, though?
Separating the user interface, what the user sees, from the business logic, the rules and calculations, and from the data access, how you talk to databases or APIs.
So if you change the UI, you don't accidentally break the core logic.
Exactly. It makes the whole system much easier to update, test, and scale without things collapsing. They use techniques like dependency injection, too.
Which sounds complicated.
Conceptually, it just means pieces of the system automatically get the tools or data they need when they need them without being tightly coupled together. It drastically reduces bugs as the app grows.
This makes the architect's technical decisions incredibly important then. High stakes. Question 6.2 talks about assessing impact. What's an example?
A common big decision. Do we build this core feature using native code, Swift, or Kotlin, which usually offers the best performance? Or do we use a hybrid approach, maybe using web views, which might be faster to develop initially?
What drives that decision?
The criteria have to be super clear. Performance needs, the specific user experience goals, long-term maintenance costs. It's a major trade-off analysis.
And in the example, they went native.
They did, prioritizing that smooth, responsive user experience above all else for that particular feature.
And the result?
A 30% increase in user engagement for that feature. The architect's choice wasn't just technical preference, it was a strategic bet on what would deliver the best user satisfaction and long-term value. These decisions are often expensive and hard to undo.
Right, you're locked in to some extent. Okay, final role. Mobile development manager. This sounds purely strategic now. Projects, resources, teams.
Exactly. The manager is the interface between the tech team and the broader business strategy. They're adopting agile, running sprints, question 7.1, but their priority list is driven by user feedback and business impact.
And success looks different here.
Totally. The metrics are managerial, delivering a major app update a month ahead of schedule, improving the App Store rating from, say, 3.5 to 4.8 stars. That's manager-level success.
It's about delivery and overall product health, not code specifics. But what about when things go wrong? Unexpected problems. Question 7.3 touches on this.
That's where you see real management skill. The example involves a major, unforeseen technical integration issue threatening a release. The solution wasn't just code faster.
It was about process and leadership.
Right. Implementing emergency daily stand-ups for hyper-transparency. Finding a clever, temporary workaround to get a crucial beta version out on time. Meeting the business commitment.
And then learning from it.
Absolutely. The key was demonstrating adaptability under pressure, keeping stakeholders informed, and then immediately feeding the lessons learned back into future planning and testing to prevent a recurrence.
Okay, so pulling this all together, for you, the listener, what we've seen is this incredible journey. It starts with mastering the tools, like a debugger, to figure out what went wrong in a small piece of code.
Technical problem solving.
And it evolves all the way to leveraging architectural patterns and leading teams to design how entire systems should be built for the long haul,
Right.
for scale, for maintainability. It's a massive shift in leverage.
It really is. And that thread of continuous learning we talked about, it changes too. At the manager level, it's not just about your learning, it's strategic.
How so?
Encouraging your team. Maybe sponsoring trips to big conferences like Google I/O, running internal hackathons to spark innovation. It's about fostering that culture of learning to keep the whole team and the product competitive. It drives morale too.
We've covered a huge range of skills today, from finding that one tricky null pointer exception to designing systems used by potentially millions. So the final thought for you listening.
Where do you see yourself?
Right. Considering this whole path, which endgame role resonates more with you? Is it the deep, specialized technical mastery and system design focus of the architect? Or is it the broader focus on people, process, and business outcomes you see in the manager role? Which path would best leverage your skills to build that next great mobile app?
Something to think about until our next